It is time now to talk about channel processing. In each one of these, as you can see, I have some channel processing mostly, some of them I don't, but most of them I do have something at least. Now what I did first for each and every one of these separately would be reductive EQ. And what does that mean? Well, you're listening to the song with all of those things already applied and done. Now we're going to run through those. I'm going to show you what would be the first step. So the first step for me would be reductive EQ. So the first step would be removing frequencies that we don't need out of sounds. Now why do we do this first and let's say not add some frequencies? Of course, sometimes we can do a few steps of processing for a sound at the same time. So let's say we do some EQing, we do some compression on top of that, maybe some special processing, and that's done. We're done with the track. Now there is a reason we do reductive EQ first, and that's removing frequencies that we don't need out of sounds, so that after that fact we can have a better insight into what we have and better judgment into what frequencies we should add. So we should first do reductive EQ, removing frequencies we don't want out of sounds. Then maybe some, additive EQ, so boosting some of the frequencies that we do want more compared to others in the frequency spectrum of what's left of the frequency spectrum after we, reduced the frequencies we don't need. And that's in, changing the balance of the sounds so they would fit our needs and our production, so they fit better together. Now, most of the reductive EQ we do so that we don't want those frequencies in there. And why? Well, because those frequencies are going to be mixed with, other elements that should be in that, frequency space, like kick and bass. They should be in the low frequencies of our song. And we shouldn't have, let's say, what is this, a clap? Well, I don't want that much bass out of this clap. Let's hear that. Now, without the EQ, I hope you hear that difference where we have a lot of those low frequencies right there. Now, we don't need those. I don't need those low frequencies out of this clap, or maybe out of this clap, or even out of these hi-hats. As you can see, these hi-hats were cut all the way up to 1K. So at this point, you're making a decision which frequencies you don't need, which are those that out of that sound you actually do not require. For everything I need this hi-hat to be is not in the lows. So this lower information, I'm going to isolate only that for you. Let me disable this. Okay, so I'm going to isolate all those lows out of that hi-hat that I'm actually not using. I don't know if you can hear that. Let me volume that up. So that information is in my hi-hat. I really don't need that in my song. Now, how would you know if you need that or not? Well, experience first. So you need to practice, and to get good in music production, audio engineering, anything like that, practice is what makes you hear better. Practice is what's going to allow you to, notice what is wrong. Now, we could play a track that doesn't sound that well produced, that wasn't that well produced to anyone, and usually anybody who listens to a lot of music would tell you, well, this doesn't sound that good, it's not that well produced. Almost anyone could say that. Almost anyone could, discern the difference between a well-produced song and a badly produced and mixed one. But if you ask them, like, okay, so what is wrong? What should we fix? Not too many people can pinpoint the exact things. And as you practice, you'll be able to point out the details. So maybe we have a lot of people who could say, okay, the kick drum is too high. A lot of people could notice a difference like that. But if the difference was in a certain frequency that the kick drum had and it didn't need to have it, like something we need to remove with reductive EQ, well, for something like that, you need more practice. And the more detailed you want to hear production, the more you have to practice. This is an exercise for your brain, so that your brain decodes the sounds better and you can hear with more detail. that doesn't come overnight, and that's not something that's, acquired by talent and, being born that way. You actually have to work for it. So the more you mess with EQs, dynamics, any kind of effects, the more your brain is going to try to hear the difference, because that's what you are trying to do, and the more you'll be able to actually, because you're practicing. So let's see, those frequencies I removed, I don't need them. So this is what I need out of my hi-hat. Okay, this bottom, no. That would be actually playing on top of my bass and kick drum, and why would you need that? Do you actually hear that in the song? Would you hear that in the song? So let's see if I unsolo that and play the entire thing, just like now. Not an entirely huge difference, I must say, so those frequencies do not add any quality to my song. Now you might ask, well, why would you cut them off then? If you don't really hear them, if the difference is not that high, why would you cut them off? Well, this is only one hi-hat and one piece of one sound that I don't want in my production. Imagine if all that built up, so I left the lows out of this one, out of this hi-hat, out of this hi-hat, if it had any. So imagine all of those left that junk, all those frequencies I don't need inside my production. Well, that would be a mess. That wouldn't sound as clean or as polished or well produced as it maybe does now. So definitely it would sound way worse. Now let's see, after we do all the reductive EQ, so let's say removing low frequencies out of sounds, or maybe even removing some resonant frequencies out of others. So now, as I don't need any of those low frequencies out of this ride, I can show you those too. So I don't need those don't do anything for me. I don't want those in my song. I want the high frequencies out of this ride. And I'm going to check if there are any low frequencies I want to remove. Usually, I would hear those first and then decide to remove them. But there are some resonant frequencies maybe in it that I wouldn't want in my song. Now, I'm not going to remove them just by hearing the ride alone. I'm going to play the entire drum section right there and see if there's anything I need to remove with them. Because right now, it actually seems fine. Sounds good with everything, being mixed in. But now I'm going to check if I remove any of those, highly resonant pieces, is it actually going to sit better with the entire drum section? So I hope you can hear the difference in what comes out of right here. I'm going to accentuate it for you. And usually the best way to find something like this when you actually hear something is wrong, and that's what you need to practice for, is this. So boosting those frequencies, making a negative change, actually boosting up what is wrong so you can actually recognize it. Now, I must warn you, when you do something like this, a really narrow, boost in some frequencies, all of those are actually going to sound resonant, as you see when I sweep up and down, but these are the ones that I actually mind, this hissing sound. So I found it, I'm just going to pull the gain downwards. So that's something I don't want. Now, this is what I would do to all of the sounds first, and then once I have removed everything I don't need, then I would start judging on, should I push something up? So should I add some frequencies? Should I boost a certain frequency range out of any of the sounds to make them cut through this entire mix better than they are already? And the reason for that, now that I have removed everything, unnecessary, now it's easier for me to judge if I should add something. If I started adding before removing frequencies, I think maybe I could even make a bad judgment on that I should actually, add some frequencies, where in fact I shouldn't. I should just remove what's wrong, and then everything would cut through much easier, since there is no junk frequencies from all of the other elements to, interrupt with the sound in question. Now, what I would do next after I've done all of that, after I've done everything I can, for the frequency spectrums of each one of those. So after I've dealt with the balance, meaning I've removed all the frequencies I don't need, I've boosted the frequencies I want out of certain sounds so they would cut better through the mix. And we already did this, let's say to this clap, where I added more high frequencies in the mid part of the signal, or everything that is mono, so it would sound better when it's played in mono, when entire track is played in mono. After that, I deal with compression if needed. So I wouldn't compress things if there is no need for it. I would compress things if I hear that I need compression. In order for you to know if you need compression is to actually practice. So compression can be used in many different ways for many different reasons. And if one of those reasons appears on one of your sounds, you should add compression. Now, let's say on one of these drums, I'm sure that I have some compression on at least one of these. And I'll show you, let's say on the sub, I have some sidechain compression, meaning that there is a compressor on my group of the sub, and I put that onto a group and not on the channel solely. But I use this sidechain compression to remove the sub every time the kick plays, so that my low frequencies don't interrupt each other, so they don't maybe destructively add to each other, so canceling each other out in the phase, or even multiplying that certain frequency where they actually are in phase, creating problems for me in the mix. So that's one of the things I would do with compression, removing things, using it as a sidechain. Or I would use compression as I have, let's say in this bass, and even more with more complexity, I would use multiband compression. Now this compressor has upward compression, so has some expansion, as they would call it, although expansion is actually noise gate with adjustable ratio. But it would expand with this setting the dynamic range of the sound, and with the other part of the setting it would actually reduce. So what I can show you right here is, let's say on this master track, which handles all three of these bands. So I have the lows, the mids, and the highs separately, and I also have that same entire compressor on top of all of those. Then together they're all routed into this one at the end. So this is a transfer curve right here, and let's say if I left it just like this, that will mean that there is no compression. So this is a transfer curve, the input and the output. If I input, let's say 0 dB, that 0 dB is going to go out. See, just like that. So I input 0, goes out 0. I input -3, goes out -3. This transfer curve is now linear, and there is no change in amplification to the sound once it goes through the processor. If I did this, any sound louder than this limit right here would get limited. So if I go in, let's say -3, goes out -3, go out -1, goes out -1. But if I go over that point, so let's say that on the input, I come in with a +3 volume, so over this line, it would still go out as 0. So any value above 0 would go out as 0, since I'm limiting at that value. I could actually also compress, just like this. So let's say from this value of -6, I'm compressing. So anything up to -6 is not affected. I go in, let's say -12, goes out -12. But if I go over this threshold line right there, so it's a regular compressor, it would go out less and less than it actually came in at. So if I go in at, let's say, +3, goes out in -3, really compressed. That's what I can do with this transfer curve. Apply compression. Now I can also do other things. I can apply that, as we call it, expansion, upward compression. So what I'm doing now is I'm adding more volume to the sounds that are low in volume, meaning that, let's say if you look at the transfer curve right now, if I go in with, let's say, -6 right here, it will already come in as 0. So it's amplifying those. So up to this point, now the sounds up to that point are expanded, and from that point are compressed. I use that a lot, and I use that especially on these single bands. So if you look at that transfer curve, let's see that. Let's play this bass that goes through that. you will notice that there is no quiet elements right there. So everything gets loud really fast, just like that. And if I did the fast attack and release, so it keeps the volume in a steady 0 value. Now I don't want anything aggressive like that. I just want to boost a tiny bit of the low volume sounds, and once they reach a certain point, I want to control them. So this is what I will do. So I do allow some differences, although this is really, really harsh and hard compression, but I do allow some differences. And then I'm gonna equalize those with this saturation right here, which is going to cut off anything that passes this red line you see right there. So you see, look at that. Now if I disable it, I'm gonna do that while it's playing. So you see, it's hard cutting any signal above that, threshold, above that ceiling of saturation. And it does that differently than, as a compressor is limiting. So saturation has a different algorithm, the way it does it. So I use a tiny bit of compression to tame the sound and a tiny bit of saturation too. Just like that, in tandem. So those two take care that my sounds right here, as many of them as there are, you see all different ones, they all sound really similar in their spectrum, response. So I'm making sure that all of those sounds have like a similar amount of low, mid, and high frequencies, so that they're not all that different. And then the volume between them is handled by that last master compressor. So I have a multi-band compressor right here, and I also have a single band on top of all of those three. So all those three get added back together through the master. And essentially I have a multi-band and a single band compressor serially in this plugin at once. So this is what I use to control the dynamics of this, mid and high range bass, because this one does have no sub. This is where the sub is. So together. So why do these have no sub? Where did I cut that off? Where is the EQ cutting off that? Well, I have that right here, so I can implement a low cut right from within this compressor. So I implemented a low cut at, let's say, somewhere 80 Hertz, and at 80 Hertz, nothing exists below that. So this compressor actually serves me as a device that's going to cut off all the sub frequencies from out of these basses, make their, in this division, low, mid, and high frequencies approximately always the same, volume. And plus I have a single band compressor on top of all of those to make sure that whatever comes in after these three have mangled the sound, it also stays in a nice controlled volume. Now I do this pretty harshly because these sounds are already quite distorted, and this is what they sound like. I wouldn't implement this in another type of music, let's say something that has a more subtle kind of instrument, like, I don't know, deep house or rock and roll, or I don't know, any kind of instrumental music. But exactly for this specific example where I have any kind of bass music, where I use different kind of bass sounds all one after another, and I want them to sound cohesive and, similar, this is what I would use. So you can use any other multi-band compressor to achieve this similar effect. I just prefer this one. Now, after we've done any kind of, compression, of course, EQ first, compression, we can do that saturation on any other track that we feel could benefit from some saturation, because saturation is going to add linear distortion, which adds harmonics that are tied to the fundamentals. So it's going to add harmonically pleasing content to our signal. And after we've added that, I could also deal with some, reverb, adding reverb to certain sounds, like maybe this crash, where I have added some reverb to the crash on all of these sends. So on these return tracks, I have some reverbs These are all impulse response convolution reverbs. I have some different reverbs. They all send out just wet signal. And I can send this crash to not only one reverb, but a few of them at the same time. So I'm sending this crash to the second three reverbs like that. So this one, and that one. Let's see what that sounds like. That's with the reverbs. This is without. So maybe you don't hear the difference now, and maybe I didn't add, in your opinion, enough reverb to it, but I actually didn't want any more. And as far as I'm concerned, I think I have too much reverb in this track. So I will back off on that once I get to the mixing stage. For now, I added those reverbs so that the track sounds alive enough, and has enough depth and, depth perception. So I created a nice sound stage so it sounds cool enough so that I can, continue with creating the ideas. It sounds cool for me at the present moment, so that I get inspiration on, which kind of elements to add next. And that's all. I would do, of course, all the detailed mixing and production processes after the fact that I've done, the idea and the arrangement, of course. And all the elements are actually in the right spot. They're playing where they should be. Then I can concentrate on mixing.